All right, I want us to consider dividing two complex numbers. So we have the complex number 3 plus 2i divided by negative 2 plus 4i. So complex numbers have a real number part and then an imaginary part here, like this. So the real number part is 3 and the imaginary part is 2i. So if you're dividing two complex numbers, remember the rule is in mathematics, the mathematical protocol or etiquette, if you will, is that you can't have a problem that has a radical in the denominator and it to still be considered to be in simplest form. So because I is the square root of negative 1 by definition, with the problem in this format, we do have a radical in the denominator because I is a radical. Okay, so this is not in simplest form. So to get it in simplest form, somebody pretty smart figured out that if we'll multiply both the top and the bottom by what we would call the complex conjugate, then it'll remove the radical in the bottom. So the complex conjugate of negative 2 plus 4i is negative 2 minus 4i. So negative 2 minus 4i, I'm going to multiply both the numerator, which is this, and the denominator by the complex conjugate of the denominator. So the complex conjugate has the same first number, negative 2, but an opposite sign in the middle. So it has the first numbers here and the last numbers. So negative 2 and negative 2 is the first number, and 4i is the last number, but it has an opposite sign in the middle. And that's called the complex conjugate. So a conjugate, that idea of a conjugate. So notice if we multiply the top, we're going to use the FOIL method, kind of like when you do first, outer, inner, last. So if I multiply there, what do I get? Negative 6. And then I'm going to do 3 times negative 4i. What is that? Negative 12i, just multiplying there. And then I'm going to do the 2i times negative 2. So 2i times negative 2 is negative 4i. And then 2i times negative 4i, that's negative 8i squared. So I times I is I squared. So 2i times negative 4i is negative 8i squared. Now, we can do the same thing on the bottom. We could do the whole FOIL method, but what we have discovered is that if you do the entire FOIL method, the outer and inner terms are always going to cancel out. So because they're always going to cancel out, there's a little bit of a shortcut. So we really only have to do the first terms together, which that would be what, 4? Negative 2 times negative 2 is 4. And then 4i and negative 4i is negative 16i squared, negative 16i squared. So we really only have to do the first and the last terms if they're conjugates, and these are. So on the top, we had to do the whole thing because they're not conjugates. But on the bottom, we just do the first and the last because the outer and inner terms are going to cancel out. So we're supposed to know a couple facts. First of all, we're supposed to know that I equals the square root of negative 1 by definition. The people who devised this defined I as the square root of negative 1. And because of that, I squared, I'm going to do that over here. Because of that, I squared is equal to negative 1. So this is a fact that we're going to use. I squared is equal to negative 1. So if we use that over here, notice that we could change this to positive 8 or plus 8, because if I squared is negative 1, negative 1 times negative 8 is 8. And down here, this would be 4 minus, if I squared is negative 1, and it is, then that's negative 16, which really makes it 20 on the bottom altogether. You see that? So now what I'm going to do is I'm going to do some simplification. So I could add this -6 and 8 and call it 2. -6 plus 8 is 2. And then I'm going to add these two I terms together. So that's 16I. And then on the bottom we had 20, because there's 20 on the bottom. Now the rule is, if you could take a number out of all three of these locations, you should. So I could take at least a 2 out of all of them. So 2 goes into there 10 times, 2 goes into there 1 time, 2 goes into there -8 times. So my final answer is going to be that. So this is my final answer to that division problem. And notice I no longer have an I term in the denominator. Now, a lot of people will split this 10 up and write it as a fraction. So 1/10 becomes 1/10. That's a 0 right there. 1/10. And then this is -8/10 I. That 8I/10 becomes -8/10 I. And I could reduce that, but because I want to keep the denominators the same, I think I'm just going to leave it like this. I mean, I could take a 2 out of each one of those there and call it 4/5 I, but usually that answer is sufficient, and then this, keeping with that same denominator, would be sufficient. So there is that. Now I want to show you one other thing, though, before we finish here. So keep that in mind. So this was our answer here. So hold on to that. And let me get my calculator, because I want to show you something here that you could do. Now, I don't recommend that you just do this all the time, and your teacher probably wouldn't want you to do this, but I do want to show you because it's a great way to check your answer. So if you have a TI 84 plus or something like that, a Texas Instruments 83, 84, something in that range, what you can do is push mode here. So on the calculator, you see mode right there. So if you push mode, and notice this menu here, if you scroll down and get here where it says real number and go over to the A plus BI form, that's complex number mode, and select that, and then hit second and quit and get a clear screen, then you can type this problem in up here. Notice what I'm going to do. So in parentheses, I'm going to put 3 plus 2, so 3 plus 2, and then I need an I. Well, if you look down here on your calculator, right there in blue above the decimal is an I. So if you'll hit second and that plus sign, you get an I term there. So 3 plus 2I, and I'm going to put a parenthesis there. So that's my numerator there, 3 plus 2I. So I have 3 plus 2I on here. And then I'm going to divide it by, and in parentheses, I'm going to put -2 plus 4I. And again, to get that I term, it's the second feature, or the blue feature on this. So I hit second and period to get an I there. And I close the parenthesis out. So what I have done is I've typed in this problem with the calculator. Notice my parentheses there. So if I'll hit enter, I'll get a decimal answer. But what you want to do is hit math, this math here, and with it on fraction and math, hit enter twice. Uh-oh, it's saying there's an error. Let's see where the error is. Go to, what is wrong? I'm not sure what it, well, it's not wanting to do that for me for some reason. Okay, well, there's a way around it. So let me go back to what the answer was here. Let's see if I scroll up. No, yeah, if I scroll up, it's up there somewhere. Okay, there it is. Yeah, see that answer? For some reason, it doesn't want to convert that for me. I'm not sure why. Let's see, where did that 84 divided by 2 come from? Maybe that has something to do with it. Oh boy, this has a whole bunch of stuff on it from a previous calculation. Let me clear all that out. I'm going to hit second and memory, and I'm going to clear entries, I guess is what I want. Let's see. So now I may have to type that in again because I'm not sure. Could be a couple things. Could be, and this is a good, I'm doing this because the reason I'm continuing to go instead of redoing this is I'm going to clear all list from a previous thing that I did, make sure everything's out. I might not have cleared the calculator before. Okay, let me try that again real quick. So 3 plus 2i. The reason I'm doing this is it's a good learning experience for all of us to learn how to problem solve a little bit. So when you get an error message, you can do what I did, and that is go to the error and see where it was, and it's saying that it took me back to the original problem. So anyway, so I've got this answer. Now in the past when I've done this, it did, if I hit math and hit frac, enter, it would convert. Okay, so it wasn't that I had it cleared out. It just doesn't want to convert that. Well, that's a bummer. I was doing this on somebody's calculator last night, a problem like this, and it didn't have any problem converting it. So yours might just be fine too. Well, I'll tell you what, I've got a way around that. Let me just type in, so I'm using that 0.1. 0.1, that's 1/10. Now, so when I come down here, 0.1, if I just do it individually and type in 0.1 and hit math and frac, it converts that to 1/10. So I could write down 1/10. Do you see what I'm doing? So I'm taking I took just the 0.1 all by itself and converted it to a fraction. And then I'm going to take the that answer that I got up here. Let's see, I'm scrolling up there so you can see it. The negative 0.8. So I'm going to take 0.8 so 0.8, and I'm going to hit math, and with it on fraction, hit enter, and I'm going to let that convert. Well, it did convert it to 4/5, so maybe, I could write negative 4/5. I didn't type the negative sign in here, so that negative 0.8 got converted to 4/5, which would be negative 4/5 here. So another way of writing the answer is 1/10 minus 4/5 I. So I got that answer on the calculator. The only difference is it did give it to me as a decimal up here. So that's kind of a nice check, and on a lot of the calculators, it'll go ahead and convert it to fractions for you. It's just not doing it for me right now, so I had to do it individually there. But I would be able to verify that that is my answer. So you can do that on your calculator. But one thing you need to remember is that if you do that, then you want to go back to mode and come down here and put it back in real number mode when you're not doing this anymore, so that it doesn't mess up future calculations for you. So you want to be able to be in mode and it be in real number mode most of the time, especially for graphs and things like that. But you can put it in A plus BI form to do multiplication, division, and all those different things for you. And it's a nice check. And also, if you were in a super big hurry, it would be a way to get the answer if your teacher doesn't mind you using your calculator. And like I showed you, you can convert it from decimal form to fraction form if you're careful and just look at each little individual term like that. Anyway, I hope this video helps you out with division of complex numbers. See you later.